All right, here we are in the second video. Continuing on, we are on number 17 now. So number 17 says, which following information does not prove that triangle CAM is congruent to triangle COM? So we're going to plug in this stuff here and kind of see what we got. Well, one thing I noticed before I even plug anything in, look at CM. CM is congruent by the reflexive property. It has to be because they're shared sides. So I'm going to mark that immediately. And then we're just going to plug this all in, and we're looking for one thing. We're looking for the ASS theorem or the SSA theorem. If you can find that theorem, then you know that you found the invalid one. Hold on, I'm coming back. People are distracting me. All right, so we need to find the theorem that makes ASS, because that's the one that does not prove they're congruent. So the first one, angle MCA, so MCA is right here, is congruent. Well, let's just focus on that. MCA and CAM. So right here we have an angle and an angle. So angle, side. Well, that's a valid theorem, so that's not going to be the one I need. Here I have a side and an angle, so I could spell ASS here. So AC and OC, so let's find AC. Here's AC. And then angle ACM. Ooh, that looks like it's going to be in the middle, so that says SAS, so that's okay. We're okay with that one. Let's go to the top triangle this time because I just wrote in that one. So the top triangle, let's try using these second ones. OC, that's going to be this guy right here. And COM. Ooh, I think we might find it right here. Angle, side. That's the bad theorem. Let's double check though. This next one. CA is congruent to CO and AM. Well, those are both sides. So if I put this over here, that just proves it using SSS. I know you can't see that actually, sorry. SSS. So we know that C is the one that doesn't work because it's the AS theorem. All right, on to number 18. 18 says, based on this drawing, which of the following rules can be used to prove that those triangles are congruent to each other? This should be a dead giveaway because you see this right angle right here. This is a hypotenuse. This is a leg. It's the ASS theorem, but it only works in right triangles. Hypotenuse, leg. Number 19. Number 19 says ABC is an isosceles triangle where AB is congruent to BC. This side is congruent to this side. That's really important because it also tells us that angle A and C are also congruent to each other, which is really important because here it says angle A is 5x plus 30. And it says angle B is 2x. Find the measure of angle C, and they want a specific number. We do know that angle C and angle A share the same equation. Well, if you have three angles of a triangle and you want to figure out what they equal, we know they have to add up and equal a specific number, that specific number being 180. So we're going to add those three angles together. 5x plus 30, plus another 5x plus 30, plus that 2x. We'll put it in the x column. So 5 and 5 and 2 makes 12x. 30 and 30 makes 60, and we'll set it equal to 180. Subtract 60. I get 12x equals 120. Divide by 12, and x equals 10. If you jump into this and circle 10, you're going to be wrong. Holy cow, I have nothing on there. I'm sorry. There's the math I just did. So once we do this math right here, once we solve this all out and we get x equals 10, we got to plug that back in and find our answer. Well, we wanted the measure of angle C. Angle C, we said, was the same as angle A. So we're going to plug angle 10, this measure of x equals 10, into the 5x plus 30. So 5 times 10 plus 30. 5 times 10 is 50. 50 plus 30 is 80. So it looks like answer B is going to be the correct choice. All right, flipping it over. Number 20. Number 20 should be nice and easy. It says, what are the coordinates of the image of the point negative 412 under the dilation with the scale factor 4? Remember, scale factors are easy. It just means multiply. We're going to take that point and multiply by 4. So negative 4 times 4 is negative 16. 4 times 12, 48. So C is the correct answer. Nope. Bye. All right. Hopefully that one should be super easy. Going on to this next one. What is the measure of angle P in the figure below? This is just like that one we just did, but easier because there's no algebra in this one. In fact, they just made it numbers, so it should be nice and simple. See how this side is congruent to this side? Well, that tells me that that angle and that angle across from those sides have to be congruent. So if that's 66, that's also 66. And they said, what's the measure of angle P? So we can put an X there. Well, this is one of those triangle sum problems, but instead of adding up an equation, we're just going to add up those two numbers that we already know, which gives me 132, and then subtract that from 180, because 180 minus 132 will give me the missing piece. So we know that if we put a 48 here, 48 plus 66 will give me 180. All right, this one right here comes from our circumcenters, which we would have talked about in chapter 5. So there's a little rule that we use, or a little trick that we can use to remember this. It says to locate the blank of a triangle, you construct the medians on each side. So I remember the acronym PAMA-SECO. P stands for perpendicular bisector. A stands for angle bisector. That's the first A. This one stands for median, and the second A stands for altitude. Over here, the first C stands for circumcenter. The second C stands for incenter. Sorry, the I stands for incenter. The second C stands for centroid. And this O stands for orthocenter, which makes this super easy. The blank of a triangle can be found by constructing medians. Medians go with centroid. Centroid is A. And we're going to use that for the second one as well. To locate the blank of a triangle, you construct the perpendicular bisector. Perpendicular bisector goes with circumcenter. Circumcenter is A. All right, 24. 24, list the angles in order from smallest to largest. And this is super easy based on the number of sides. If you do the sides from smallest to largest, you can figure it out. So for example, the smallest side is 4. You look at the side or the angle that's not touching that side, and that has to be the smallest angle. So since 4 is the smallest side, angle C has to be the smallest angle. The next smallest side is 5. 5 is not touching A, so A is the second smallest. So you can see we have CA, B is across from the largest side, so B is the largest angle. All right, 25, you can use special right triangles here to find this missing side. It says find, if this is a square, each side is 80 units, find the length of the square's diagonal. Well, one thing I noticed is that if this is 80 and it's a square, this also has to be 80. And you could use special right triangles here to make this really easy, but if you don't remember special right triangles, you struggle with them, you could also just use Pythagorean theorem. 80 squared plus 80 squared, that's A squared plus B squared, equals the missing side, C squared. So 80 squared is going to give me 6,400, and over here we get another 6,400 equals C squared. And we add that together and we get 12,800. It's looking like a big number, equals C squared. Well, we just square root both sides. And remember I told you earlier there's a nice trick because we're going to get 113.14 here is equal to C. Well, I need to figure out what number matches over here. Well, we know it's not 80 or 40 because those are nice whole numbers. It's got to be 80 square roots of 2 or 40 square roots of 2. So let's start by doing this 80 square roots of 2. In my calculator, let me see if you can see some of it. I'm going to type in square root of 2 first, so I'm going to press 2 and then the square root button. So I get 1.414213562. And I'm going to multiply that by 80, the number in front of the square root. And when I do, I get 113.13. So that looks like it's my correct answer. Next up is 26. 26 says, in triangle DEF, DE is 7 centimeters and EF is 12 centimeters. Which of the following could be a possible length of DF? This is where we use this thing called the triangle inequality theorem. And all we do is subtract these numbers and add these numbers to find a valid range. So if you do 7 and 12's difference, what is 12 minus 7? Well, I get 5. And to get the highest number it could be, we add them together. 7 plus 12 gives me 19. So I know I have to pick an answer that's in between 5 and 19, not including 5 and not including 19. So for example, 5 is the first valid answer that we could pick, but that's not between 5 and 19. It is 5. Same thing, C. 19 is on the scale, so it can't be 19, meaning the only possible answer that's between 5 and 19 is 10. Those are easy questions. Easy, easy peasy. 27 says, which is the classification of a triangle? Is it acute, right, or obtuse? We could make some guesses looking at it, but they didn't tell me how big this side is, which makes it really difficult to do anything else. They didn't tell me any of the angles, which is what we really need. There's nothing I could do. If they gave me this side, I could use the Pythagorean inequalities to figure it out. But considering they gave me nothing there, there's really not much I can do. So we're going to say not enough information on this. All right, 28 is a kite. Kite properties are a little bit confusing sometimes. I think some of us might see it though. See how this side and this side really look the same? They are. This is 100. This is also 100. These two do not have that relationship though, because these two sides come up and make a bigger angle, and these two sides come up and make a more narrow angle. But really easy if you understand what we did in triangles. This is super simple. In a triangle, we said all three angles have to add up to 180. Well, in a quadrilateral, all four angles do the same thing, but instead with 360. So we're going to add these up and subtract them from 360, and that will give us x. So 100 and 100 makes 200, and 200 plus 93 is 293. And we subtract that from 360, and it looks like I'm going to get 67 as my answer, so B. (29) Each of the following statements about similar pentagons DEFGH and JKLMN is true, except the ratio of the corresponding sides of the pentagons is 2 to 1. I don't really know. Let's pause on that though. And the reason I say pause on that is because the next statement says pentagon DEFGH is twice as big as JKLMN. Well, doesn't the ratio of 2 to 1 just means twice as big? And if we're picking the one that's true, except, well, if one of those is true, the other one has to be true. If one of those is false, the other one has to be false. They say the same thing. So that can't be the answer because we can't pick it, or else the other one to also be picked. Both pentagons have corresponding angles that are congruent, possible, and pentagon JKLMN is the result of translation pentagon DEFGH. I'll tell you right now, C is also true, and we'll learn this next semester. We haven't talked about similarity yet. Similarity says that the angles have to be congruent. For JKLMN to be a translation of DEFGH, that would mean that this would literally have to move and stop. Doesn't it look like it moves and then gets smaller and maybe even rotates? That is not just a translation. That's more than just that. So the one that's true except, this one is the except. D is not true. All right, flipping the page. Number 30 says, two trapezoids in the figure are similar. ABCD is similar to LMJK. The lengths are known. And the lengths of BC, CD, and JM are known, and what other side of the length can be determined. So we're looking for corresponding sides here. BC is the middle two letters, so it corresponds to MJ. Well, BC and MJ are already included. It's JM in this, but it's included. So we already have one pair of corresponding sides. CD is the other pair of corresponding sides, and we don't know what it corresponds to according to this. We can look, though. If C and D are the last two letters, J and K or KJ are the last two letters. So we know that the other piece that we could find out has to be JK. And again, this goes with next semester, so we'll talk about it, but that's a pretty easy one. If you understood corresponding parts in triangles, you understand corresponding parts in quadrilaterals. They're pretty much the same. Now we're actually going to apply it in 31. So they said the same thing, except this time they said AB is 10, AD is 12, CD is 8, and LK is 18. Sorry. Yeah, LK is 18 right here. What is the measure of LM? So they put an X here. One of those things is not like the others. We know X and 10 go together. We know 18 and 12 go together. This 8 that comes up on the right angle side is just there as a confusing piece. So we're going to set up a proportion. This side's proportion is 10 over 12. And we're going to set it equal to this side's proportion, which is X over 18. Again, this is some next semester stuff, but you guys might remember this from your middle school years. This is just a proportion, and to solve this, we cross multiply. 12 times X is 12X. 10 times 18 is 180. So we have 12X equals 180. We'll divide both sides by 12. And when I do that, I get X equals 15. So we're going to pick B. All right. Desiree has two flower beds in her backyard. The flower beds are meant to be similar rectangles. Great, let's draw that. There's one rectangle and there's a similar rectangle. The length of the larger bed will be 8 feet. There's an 8 on the length. And the length of the smaller bed will be 4 feet. Desiree wants the width of the larger bed to be 5 feet. For the flower beds to be similar, what would be the width of the smaller bed? I think you might see this. The width right here is what we're looking for. 4, 8. This one is twice as big as that one. So if this goes 4 to 8, then what has to go here? Well, half of 5 is 2.5. So A has to be 2.5. And again, you could do this as a proportion. You could do 8 over 5 is equal to 4 over x, cross multiply, and you get 2.5. I like that way better though, just seeing that it's double. Last question we're going to do in this section. An equilateral triangle is contained within an isosceles trapezoid shown above. What is the measurement of the largest angle within this diagram? This one is a nice, oh, it says ignore the straight angle because we know straight angles will be the largest. This is also a nice simple problem. If this is equilateral, we also know it's equiangular. And in an equiangular triangle, all three angles have to be 60 and 60 and 60. Well, it looks to me like this angle right here is a nice obtuse angle. And the obtuse angle is easy to find because if these make a straight line, 60 and this angle right here, x, they have to add up to 180. So we're going to take 180, subtract 60 from it, and we get 120. So this has to equal 120, meaning the largest angle is 120. All right, and we'll pick up on the next video from here.